So here's the problem, okay? And what usually gets presented to you is, have a look at the whole thing. It starts like this, okay? And when you have a look at this, what it appears to be is one big triangle that's cut into pieces. Yes? So far so good? And you can look at the dimensions of the triangle. It's got a height of, looks like 5. Yeah? And help me count, what's the width, or the base rather? What's the base? 13? Yeah, okay, 13. Right? So you got this 5 by 13 triangle, okay? Now in the animation, and you can verify, you can see what's going on. These two pieces have swapped, but then these two pieces have been rearranged a little bit. And suddenly, you've got the same 5 by, you can count it and double check, 5 by 13 triangle, right? But now there's a hole, right? So the area of this triangle here is, well, it's going to be 5 by 13 on 2, right? Which I think is 32.5 units. Yes? Okay. But then you have a look at this thing, and you're like, well, it's going to be that 32.5 units minus 1. Because there's something which isn't covered by a coloured thing, right? So how is it that just by rearranging, we have made a square disappear? Okay, take it.
It's because of the slab, the area that's covered by the angle, like the slab, the parts of the slab, they've changed.
Okay, good, right. Let's go on this idea. Slant is exactly the nature of the problem. I think if you could summarize what's the problem with this, because it's not really a paradox, it's a bit of a cheat. Really, it's an optical illusion, okay? The reason why is slant is the issue. It looks like, remember I said this, it looks like it's a triangle, doesn't it? Okay? This thing here. But in fact, it is not a triangle at all. It is actually a quadrilateral. Okay? Do you want to give us some more detail, Raphael?
Because the gradient of the blue triangle is different to the gradient of the red.
Very good. Okay, so there's a couple of ways you can talk about this, right? Because you guys know trig, it might be easiest to talk about it in those terms, though you can see it without, okay? Have a look at the blue triangle. You can see that its dimensions are 2 by 5, right? 2 by 5. But if you have a look at this triangle here, it's 3 by 8, I believe, right? 3 by 8, which is not the same. These two triangles are not similar. They look similar, but they're not actually similar. Okay. Now, because they're not similar, you can use trig to do this. But actually, yeah, let's do that. Get your calculators out. Get your calculators out. Now, suppose I just rephrase the question a little bit. It is drawn on a grid, so even though the triangles aren't what they appear, they are still right-angled triangles. So, for instance, let's have a look at the blue one. I've got a right angle here. Okay. So, use trig. How might we determine, for instance, what the size of this angle is? How would we work out its size?
Tangent.
Yeah, you'd use tan, wouldn't you? Because you got 2, you got 5, that's opposite and adjacent, right? So you would say tan of that angle, let's call it theta, is 2 over 5, yes? Which gives you theta equals tan inverse of 2/5, which someone could tell me, just give me nearest degree.
22 degrees.
22 degrees. Okay? So I can write 22 degrees up here, but when you have a look at this angle, right, instead of tan inverse of 2/5, it's really tan inverse of 3/8. Now, what's that to the nearest degree? 21 degrees. Now, 21 degrees, 22 degrees, you and me, we can't tell what the difference is between those, okay? And when you have a look at that, it looks pretty straight, doesn't it? 1 degree difference, no wonder you can't tell, okay? But in fact, if I made it really obvious, you know, this degree is a bit smaller. So it's something like this, and then you've got a different triangle up there, right? And then you've got your bits and pieces in here, okay? So this is an exaggerated view. You're like, of course it doesn't work, because this shape is not a triangle. You see there's this gap in here, see this gap, right? Now that gap is where this gap comes from, right? It's not very big, but over this space, it's just big enough to make a little square, okay? Because if you think about it, when they swap places, okay, instead of being like this shape, whoa, oh well, you're going to get this shape, okay? So you can see how this one bends inwards, and this one bends outwards, right? See, there's where the imaginary triangle is, okay? So from bending inwards to bending outwards, there's some missing area in here, so that's where the paradox lies. Okay?